Okay, so we are on level 3, module 11, that is recursion. Let's begin with the defining of recursion, the definition of recursion. It basically refers to a programming technique in which a function calls itself either directly or indirectly. Okay, so the main thing which is to be highlighted over here is that the function that we're talking about is calling itself. So when we have this kind of a condition where the function is calling itself, it is called recursion. Okay. For example, let's have a look at this small example which is written over here. Define A. This is what? This is the definition of a function named as A, and inside this part is the body of the function. And say for example there are other statements also in this body, and one of the statements is calling the function back again, the same function again. You can see over here the same name is written. Okay, so here A is calling itself from its body. So this is an example of direct recursion. The two varieties of recursion which were mentioned over here. One is direct recursion, the other one is indirect. So this first example concentrates on direct recursion. Next, we have this other example. In this example, they are going to talk about indirect recursion. So here you have the first function, which is A. So here is the definition of the first function. A, this is the body of the first function, which is calling, like so inside this function A, inside the body, along with the other statements, we have one statement where this function is calling function B. So when the function B is called, again we'll move inside the body of function B, maybe some more statements over here. And over here you can see function A has been called. So this will point back to this particular function A. So this is a way in which recursive action is being performed but indirectly. So this is an example of indirect recursion. This is direct recursion and this is indirect recursion. So we can move ahead and further try to define a recursive function and its problems. The problem with the recursive code is when it becomes endless. So this is the main problem. Okay, why recursion is avoided, or what precaution should be taken whenever we are thinking of designing a recursive function is we have to avoid this because it becomes a problem when it becomes endless. Okay, when we get stuck inside the loop and there is no end to it. That's what is the meaning of something becoming endless. So you must write a sensible recursive code that has clearly defined where to stop. Got it? So these two lines, just understand the connection between these two statements, that you have to avoid something, you have to avoid a loop which will become endless. So how are you going to do this? By following this simple technique of clearly defining where to stop. That clear definition should be inside the body of the function where it has to stop. So, a right or a sensible recursive code is the one that fulfills the following requirements. What all requirements? First is it must have a case whose result is known or computed without any recursive calling. Okay, this is called the base case. The base case must be reachable for some argument or parameter. It should not be a kind of a code that you've written that you have mentioned this base case, okay, but your parameters, the function has been designed in such a manner that you're never reaching that particular base case. Okay, so that has to be taken care of. Secondly, the second point is it also has recursive case whereby the function calls itself. Got it? So if we define any function which we want to make as a recursive function, so inside this part, here is what? Here is the body of the function. So inside the body of the function, you have to include these two things. Okay, first is some base case wherein with some condition you are going to specify that okay, here is where you have to stop. That is called the base case. And in some part, of course, you have to make a call back to that same function because you are actually going to create a program showing recursion. So this calling back should be there. A recursive case has to be there. Plus a case which is called the base case should also be mentioned somewhere inside your body of the function. Okay, so if you are going to take care of these two things, then your function, recursive function is going to work accordingly. Now, we have an illustrative example over here. Write a recursive function that computes the sum of numbers from 1 to n. Get the value of the last number n from the user. Okay, so this is a simple program. The program demands what? That you have to ask the user to enter any number and then you have to sum up the numbers from 1 to n. Simply like if you ask the user to enter some number, say for example, the user enters the value 5. So your function should perform what? Sum of numbers from 1 to 5. So it should be actually 1 plus 2 plus 3 plus 4 and plus 5. This is what has to be performed and the sum is to be returned. Okay, now let's go through this program. First of all, we're going to concentrate on the main part. This is our main part and this is our function which has been defined. Okay, this is the function definition and this is our main program code. So in the main program code, last is equals to 4. This is, as the question says, the last number you have to get the value from the user. So either this number you take some value directly as has been taken in line number 10, or you ask the user for the value. That is going to be a simple statement, something like last is equals to int, and then you input some value stating some message like enter the last value. Okay, I hope this is clear. We've already done this. So that value will be taken in this variable last. Fine. After this, now here is our function call. So this is the function. The name of the function is compute, as it is already defined also over here. You can understand the name of the function is compute. Here we are calling that function. And what are we sending? The argument that is to be sent to the function is this value of last. Okay, so within bracket we have one argument which is being sent over here. Now, the function has to compute what? The sum of numbers. So that means there has to be a return variable also, which will store the result. So this is your return variable to store the result. All right. Okay, so one argument is being returned, one return variable you're going to get over here, which will store the result, and one argument is here which you have to pass. So now, after this line is read, directly we're going to jump to line number 3. Okay, here is the function definition. Compute is the name of the function. DEF is written because it's a function. It's being defined. Inside the brackets, we have to mention the number of arguments which have to be passed. In this example, it's already clear that we are passing only one variable, only one argument. So the name given to that variable is num. All right. Now, this is supposed to be the function body. So we already know how a function is written. We write def, we write the name of the function. Within bracket, we pass the argument. Whatever is desired, then we put the colon. And next, indented, we have the function body. Okay, now if you remember, there were two things that you have to take care of whenever you design a recursive function. So one part is called the base case, and the second part is called the recursive case. You have to handle these two cases in case of functions displaying or using recursion or showing recursion. So this is our base case that if num is equals to 1, this is a simple condition that if the value of the past argument is 1, then you return 1. This means what? So this is again just go by that simple example that we had, that in case the user has passed the value of n as 1. So the answer is going to be what? It is actually what? 1 से लेके n तक you have to add up. Now n is 1 only, that means only 1. So that means in that case, the sum returned will be 1 only. So this is what the value is being returned over here, return 1 in case num is equals to 1. Else, now see, this is going to be the main part which you have to understand very nicely, which indicates actually that here is the function call. So this is what? This is return. This is a recursive function call. So return what? It's going to return num plus compute num minus 1. Okay, so this part, this is actually a recursive function call, because here it is indicating that the same function, inside the same function, you're writing the body of the function, and within that body only, you have written the name of the same function only. Right? So this means it is calling back the same function, but what are going to be the different things? What is going to differ? Differ is going to be, the difference is going to lie in the argument that you're going to send back. So we are returning num plus compute num minus 1. So let's understand this better using this example only, where the value of n was equals to 5. So when we come to line number 11 and we say compute last, we'll say compute and 5 is passed to this, and we come to line number 3 where we get the value of 5 in num. Alright, so num is equals to 5. Then it will come to line number 4. If num is equals to 1, is num equals to 1? No. So this part is ignored for the time being. It will come to line number 6, coming on to the else part. What is it returning? It is going to return num plus. So num is what? Num is 5. Num is what? Num is 5. So now it is going to be 5 plus compute num minus 1. That means now I am going to call this function compute, and now I will pass the value of what? Num minus 1. Num was 5. 5 minus 1, that is 4. Okay, so taking this value, this is going to come back to this function definition. So again, it will reach over here, and this time, now the second time, the value of num is considered as whatever is the passing value over here. Okay, that is 4. Then it will come here and check if num is equals to 1. No, num is not equals to 1. Again, it will come to the else part and it will return num plus. So what was num? This particular part is going to be replaced with what now? It is going to be replaced with 4 plus compute and num minus 1, that is 3. Remember, 5 was already there. Okay, this part I said is going to be replaced by this. So this is already there. It's 5 plus now 4 plus compute and 3. Again, this will continue and this will carry on like this. 5 plus 4 plus 3 plus compute of 2. Then finally it will be 5 plus 4 plus 3 plus 2 plus compute of 1. And now when it is going to get back to this function, and it will check line number 4 if num is equals to 1. Yes, The recent value which is passed is 1, so it is going to return 1. So this part will be replaced. Whenever it is returned, you have to understand where the value is coming back. This part will be replaced with 1. And then finally, we are going to have the answer as 5 plus 4 plus 3 plus 2 plus 1, because this is replaced with 1. So this will be calculated and your final answer is going to be returned back to SS sum, and which is finally printed that the sum of the series from 1 to 5 is, and then the answer over here, which will be 15. 5 plus 5 is 10, 14 and 1, this comes out to be 15. I hope it is clear now. This is how a recursive function works. Now, with a bit of thought, you'll realize that any functional recursive function must have such a situation as in the given example, since otherwise the recursive function will never finish. Okay, so which was that main condition that you can consider over here, which has you can say which has brought a halt to this particular function? Okay, this is this particular line, this particular code, that if num is equals to 1, then you have to return 1. If you will not have anything of this sort, if you won't have any stopping condition, any base condition like this, then it is going to be stuck. It will get stuck in an endless kind of a recursion function, which is not feasible. Okay, so in executing a program, the computer creates what is called the function stack. Now, this is what happens inside, like how the stack or how the function works actually. The function stack is a stack of frames, and each frame corresponding to a function invocation. At all times, the computer works on executing whichever function is at the stack's top. But when there is a function invocation, the computer creates a new frame and places it at the top of the stack. When the function at the stack's top returns, the computer removes that function's frame from the stack's top and resumes its work on the function now on the frame's top. Okay, so it is something like the first value of the stack, the first time the function was called, then the second time it was called, then the third time, then the fourth time, then when one after the other, when the functions are returning values. So when this returns the value, whatever is at the top, then this is popped out, so removed. Then the next, whatever is written here is executed, and then this is popped out, then this is popped out, and finally this is popped out, and you get your desired results. Okay, now this is another example. So I'm leaving this for your home assignment. You please go through this on your own and try to understand what this function is all about. One, give me a second. Where is the pointer? Okay, fine. So this is your home assignment. So it will be there as a part of the PDF also. So you can go through this and understand the function is already given. This is a recursive function to print a string backward. All right. Next, in Python, recursion is used as a form of repetition that does not involve iteration. Okay, so there's a slight difference between what iteration is and what form of repetition is recursion. A recursive definition is a definition that is made in terms of a smaller version of itself. For example, consider something like this. If you have an example where x to the power of n is actually x into x into x, and this is iterative definition, this is non-recursive, this has to go up to n times. Okay, so this can be represented recursively. So these are two different versions of one task. There is one task that you have to perform. You have to find out x to the power of a value n. So if you are using iterative definition, then this is what it means. which can simply be handled using loops. Okay, this can simply be worked out in the form of a program making use of a loop. But if you have something where recursion is involved, then the task is the same as I just said. What you want, what is the desirable result will remain the same, but you're going to twist it in the form in which you can write a recursive definition. All right. So x to the power of n can be broken down as this, that it is x into x to the power of n minus 1. So whatever task you had to do for x to the power of n, now you're doing it x to the power of n minus 1 for all values of n greater than 1. Okay. And these are your limiting conditions. If n is equals to 1, that means x to the power 1, that means x only will be your answer. And in case n is equals to 0, so x to the power of 0, in fact, anything to the power of 0 brings out the value to 1. Okay, so this is the requirement of a recursive function, and this is how the code will be used, the code would be written. So we have something like this. The name of the function, we can term it as power. So power of x comma n is equals to x into power of x comma n minus 1. Okay, straightly from this particular thing, from this particular definition, you can get this function definition. And the base cases would be when the value of n is equals to 1, then what you want the power, you have want to fix it to x. And when in case n is equals to 0, you want to fix this value to 1. Okay, so this is going to be your second homework assignment that you will try designing a program to make use of this particular power function. Okay, I think this is that only. The code is already written over here. You can just go through the code. You will definitely find it simple. Okay, so just a small briefing that I would like to say in regards to recursion is that whenever the first time you are calling a function and second time when you are calling the function, so when the function you are returning that value, so there is always some value and plus or multiplication, whatever is the desired requirement of that particular program, and then that will be the function call again with maybe a change, a variation in the argument that you're going to send. Okay, so like in this, if we just give a glance to this particular program, here is the main part, the main code. Enter only the positive numbers below. In num, you are entering the base number from the user. Then in P, you are entering the power also from the user. Here is the function call. You are passing num, comma P and getting the result in the variable result, that is result. So the moment this particular line is read, it is sent, the control is sent to the definition, to the function definition part. This is the function definition part. Here you have this is your base case. In this example, if b is equals to 0, that means if power is equals to 0, then you return this as 1. Else, this is your recursive part. This is your recursive part where you are returning what? That same value into power of a, the base remains the same, power now is different. Okay, it's a different part now. In place of b, it has become b minus 1. So 1 by 1 you're reducing and you're taking it to that limit where the power will reach 0, and in that case you are going to return a 1. Got it? So I want you to try this program also for your homework. The code is already here, so still I would like you to try it on your own and then come back to see the code in case you fail to design it. In Python, a recursive code can also be written in a non-recursive way, which is the iterative version of the same. Again, this is going to be your homework, and this is something that we have already done before. Okay, this is going to be a simple looping construct program. You have to make use of loops. As you can see over here, for loop is being used. All right. Now, some recursive codes. Now, again, I have given these questions in your assignment. So, I would like you to complete this factorial recursive program. Then GCD, that's the greatest common divisor program recursively. Fibonacci series also recursively. All these three, in fact, even binary search that we're going to discuss right now, all these have already been done non-recursively. Okay, so you already have an idea about what lies behind, like what's the code part of factorial. Okay, what is factorial of a given number? Say for example, if I ask you to find out the factorial of 5, so you know how you have to go about this using a loop. Okay, so you just have to simplify this. You just have to think it in a different way, that how can I write 5 factorial as 5 into factorial of 4? So this becomes a very straightforward thing, that it is the same value, whatever value you're taking out as the factorial, into the factorial of 1 minus from that value. Okay, this further simplifies to 5 into 4 into factorial of 3, and so on till you get the final result. Got it? So I think you can understand what I'm trying to explain to you right now, that whatever questions come up in your assignment, if you are free to write down the code, definitely you are free to use recursion or a non-recursive looping construct or iterative based construct. But if you are confined to recursion, this is how you should think about it. You have to go about it. Okay, so factorial, GCD, Fibonacci, it's not always that the line of track is going to remain the same. It might differ in certain cases. Like when you are going to decide, when you're going to talk about GCD, the greatest common divisor. So when I was trying this question personally, I felt that you have to think differently. Okay, when you are using a looping construct to find out the GCD of any given two numbers, you have a different look up at your values and towards the code, towards what logic you are using behind this. And when you're going to talk about recursion, it is a different story. It is very different in case of recursion, in case of GCD program. Okay, so this is going to be the main challenge for you. Let me see how you all can go about it. The rest are very similar to their iterative code and just writing down their recursive code. All right. Binary search, I think this also we've already discussed it before, what exactly binary search is all about. Let's go through it quickly. In this technique, a given item is searched in the minimum possible comparisons. This is supposed to be the minimum possible comparison method of technique of searching. The binary search requires the array to be scanned, should be sorted in some order. This is also again that we are aware of. This is the limitation of binary search, in fact. The items, the list in the number of elements in your array should be sorted. To search for an item in a sorted array, the item is compared with the middle value of the segment, right? If the item is more than the middle value, then the latter part of the segment becomes the new segment to be scanned, right? So if you have certain values, if say for example this is your array and you have the values, say for example 4, 2 and 5 and 7 and 9 and say 13, right? And you have to search for a given number. So what they are saying is, first of all you find out what is the middle value, and then whichever is the number to be scanned. Say for example we are going to look for 13, so 13 you are going to just compare with the mid value, that is 7. So if 13 is greater than 7, that means you only have to concentrate on the latter half. Okay, if the item is less than the middle item, then the former part of the segment becomes the new segment to be scanned, right? So this is how binary search is done. The same process is repeated for the new segments until either the item is found, that is search successful, or the segment is reduced to the single element and still the element is not found. That is the case when the search is unsuccessful. So either it is successful or it is unsuccessful. So I think we've already done binary search. Now this is binary search versus linear search. Again, it's very fast compared to linear search on single dimensional arrays. However, linear search can work on both sorted and unsorted arrays. Whereas the binary search can work with only sorted arrays. Also, binary search works with a single dimensional array, whereas linear search algorithm can work with single as well as multi-dimensional arrays. Okay, now this is again an example of binary search algorithm where we have made use of a recursive search technique. Okay, and so again, you can just try this program. We already know the logic behind this, so just have to, it's very easy. You just have to make sure that how you are deciding those conditions wherein your low and high, these variables values are to be changed. Okay. Now, I think this is the last topic, recursion versus iteration. Recursion and loops are actually related concepts. Okay, that we have already understood by going through this entire PDF, that this entire PPT, that you already have an idea, like recursion and loops, they are actually very related. Any question which is given to you which involves looping or iteration or repetition. In fact, I should say which involves repetition can be solved either by recursion or by looping. Okay, it's like that. Generally, anything you can do with a loop, you can do with recursion and vice versa. Sometimes one way is simpler to write and sometimes the other is, but in principle, they are interchangeable. Yet there are some examples where recursion is indeed the best way approach to approach a given problem. When a loop repeats, it uses same memory locations for variables and repeats the same unit of code. Whereas in recursion, instead of repeating the same unit of code and using the same memory locations for variables, fresh memory space is allocated for each recursive call. Okay, this we've already done, that stack formation, if you remember. So stack and stacks just piling up one after the other. This is utilizing the memory only. So recursion is heavy on memory, right? So this can be considered as a kind of a drawback of recursion, that it is heavy on memory because with each recursive call, there are unfinished function calls still lying in the memory. So memory use decreases only after the base case has been reached and unfinished function calls start getting completed. Getting it? So these one after the other, whenever the function is being called recursively, so one by one, now what happens is it actually means that this when we reach over here, this is still incomplete. Right? And Abhi, this is incomplete and we have reached over here. When this gets sorted out, then the memory is released and it comes down. Then this is sorted out, then the memory is released and it comes down. When the base class is also, the base condition is also sorted out, all done, then finally you can say that the memory is released. Okay, so we can summarize that recursion makes a solution looks shorter. Let me change the highlighting color. Okay. So we can summarize it like this, that recursion makes a solution look shorter, closer in spirit to abstract mathematical entity. Okay, it seems to be like this. An iteration makes a solution less costly to implement, but all logic is part of the loop, so lengthier it appears. So these are the two ways in which, like, you know what, they've given like 50-50 to both recursion as well as iteration. Okay, they've given that some this recursion is better in another aspect, whereas iteration is better in another aspect. So they've just shown or indicated us like they both have their own ifs and buts. It always depends on the problem being solved, which approach is better for it, either iteration or recursion. Okay, so I think that's all for today. I'm going to soon share the recursion based assignment with you. So just go ahead and try to solve it. Thank you.